Okay, and here we are in the third section of Chapter 7, the Law of Cosines. I will apply the objective. I will apply the law of cosines to find the value of the angles and sides of an oblique triangle. I will apply the law of cosines to determine the area of an oblique triangle. Okay, so when dealing with two angles and one side, so side angle, angle, or angle side angle, or two sides and an angle not between the two sides, side, side angle, then we use the law of sines to find the missing pieces. But if we're dealing with two sides and the angle between them, or side angle side, or three sides, side, 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 then we can use the law of cosines. So here's a formula for law of cosines. They really are all the same. A squared equals b squared plus c squared minus 2bc cosine of a. Notice it starts and ends with the same value, little a, referring to the side, to angle A. If you're looking for side B, to angle B, and so on and so forth. I know if you're one of those who took Cambridge and you introduced the law of cosines, Mr. Zimmerman used this one alone and told you guys to just kind of adjust from that. Okay, so the first objective on this one will be the side angle side. Two sides and the included angle are known. So you're going to find the third side using the law of cosines. Find the smaller of the two remaining angles using the law of sines, and then find the remaining angle using the angle sum formula. So we're going to use law of sines, law of cosines in there. Now I will throw this in step 2. You can use law of cosines here as well if you want, but we're going to just go ahead and jump on law of sines. Get you guys feeling good about it. So on this one here, what we're going to do is set up the the triangle. So we have angle A they gave us, which is 61 degrees. Little a they did not give us, that's going to be over here. Angle B they did not give us. Little b, that would be this side here, equals 4. Angle C, they did not give us. And little c is 6. And this would be little c down here. And at this time, you can see that they gave you the two sides, and the angle in between. Anyways, you have the A, B, and C going on, with one of them being an angle. So using law of cosines, since we're going to, they want us to solve the triangle. So we're going to use law of cosines to find A. So A squared equals B squared plus C squared minus 2BC cosine of A. This is when I get to throw the reminder in there. Don't forget to make sure that you have your calculator in degree mode. So on this one here, we throw all of this in the calculator at once. Well, actually, let's plug our values in. So A squared equals 4 squared plus 6 squared minus 2 times 4 times 6 cosine of 61. Okay, number one mistake that's made on this one is students will put all of this in, they'll hit enter, and then they'll do times cosine of 61. But here's what I need to throw up there. This 4 squared and 6 squared is not being multiplied by the cosine of 61. So do one or the other. Do 4 squared plus 6 squared, hit enter, and then do minus the 2 times 4 times 6 cosine of 61. Honestly, just throw it in the calculator, don't stop. 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 61. Then hit enter. Okay, this gives us an A squared value of 28.7, which gives us an A value of approximately 5.4. Okay, so then we have that, and step 2 will tell you to use the law of sines to find the next the smallest angle, because I have all three sides and one angle, I can now go, okay, I have this one. My smallest angle is going to be this guy here. Now we go after the smallest angle, that way we don't happen into is it one triangle or two triangles idea. We go for the smaller angle. It doesn't matter. This has to be the smallest of them all. And so we're not going to look at going, oh, this can be 30 or this can be, well, no, it's going to be your smallest angle. So we got to keep that one in mind. So we're going to use the law of sines. So we're looking for angle. I'm going to go for angle B because it's the smallest. Well, I'm a starter. How do we know that's the smallest? Because side B is the smallest, which means the angle opposite must be the smallest. So we have sine of B over little b equals sine of A, which is 61, over little a, which is 5.4. Well, let's fill in that little b, because I should have done that anyways. Little b is 4, so let's fill that one in. Okay. Let's try it again. Sine of b over little b, which is 4, equals sine of 61 over little a, which is 5.4. So sine of b equals 4 times sine of 61 over 5.4. And when we plug that in, we get a value of 0.6527. And then you do angle B equals the arcsine. Remember, we use arcsine to find an angle of 0.6527, which gives us an angle of approximately 41 degrees. And now from here, we can use our sum theory. So angle C is going to be 180 minus the 41 minus the 61, which gives us an angle of 78 degrees. And we're done. Okay, so this is giving us an example of that one. So let's look at another one, the example where we have 3 sides. With 3 sides, they tell us to find the largest angle using the law of cosines. This will keep us away from, what kind of triangle do I have? Find either remaining angle using the law of sines, and then find the last one using the angle sum formula. Now on your cream sheet of paper, you have all of the law of cosines and sines on it, and the different versions of it. So in class, we'll talk a little bit about what you have and how to approach them. So let me fill this one out. A equals, because we don't know any of our angles, B equals, and C equals. Now a little reminder, this is angle A, so this guy is little a. This is angle B, so this guy over here is little b, and that leaves this guy to be little c. So side A equals 5, side B equals 7, and side C equals 9. Now, if you wanted to take the chance, you can do Pythagorean theorem very quickly to see if you get a 90-degree angle, which means on that one, you do is 5 squared plus 7 squared equal to 9 squared. If it is, you have a right triangle. If it isn't, then you have to go back to law of cosines. So according to the rules up there, they told us to find the largest angle using law of cosines. So we're going to go after angle C. So on this one, now I did not give this to you earlier, but you can tweak that formula a little bit. That way you find cosine of C right away. So cosine of C is equal to A squared plus B squared minus C squared all over 2AB. Now, what I did is I took that earlier formula that was C squared equals, and I moved everything around so that I can work with it. And really what I did is I took the cosine C portion and we'll do this in class instead of trying to explain this to you. Okay, so I plug everything in. So cosine of C equals A squared, which is 5 squared, plus 7 squared, minus 9 squared, over 2 times 5 times 7. You throw this one into the calculator, and you're going to get a value of -1/10. And then do the C equals the arc cosine of -1/10. By the way, this being negative tells me it's going to be something larger than 90. Plug that into the calculator and we get a 95.7 degrees. So there's this one, 95.7 degrees. Okay, and from there it tells you it doesn't matter which angle, because we now know that this is a 95-degree angle. Find B, A or B. So I am going to go for B, angle B. So the sine of B over little b, which is 7, equals the sine of C, which is 95.7, over little c, which is 9. So we get sine of B equals 7 sine of 95.7 all over 9. So that into the calculator and you get 0.7739. So angle B is the arc sine, 0.7739, which gives us an angle of 50.7 degrees. So this guy is 50.7. And then to find angle A is going to be 180 minus the 50.7 minus the 95.7, which gives us an angle of 33.6 degrees. And then we can double check the idea that the smallest side has the smallest angle, the largest side has the largest angle. Now, one thing I can throw out there, you found the first angle using law of cosines. You can continue using law of cosines for the next angle as well. You don't have to go to sine if you don't want to. That just reinforces sine, so you go, oh, I know what I'm doing. And you're all good. Okay, so this video, I believe, is, it's 14 minutes. Let's do one additional example, and then the second video will be, we'll do more examples. So on this one here, well, right over here, A equals 67.3 degrees, and little a we don't know. Angle B, don't know. Little b is 37.9 kilometers. Angle C, we don't know. And little c is 40.8 kilometers. Okay, so according to this, the directions on this one here is we use the law of cosines to find our last side. So a squared equals b squared plus c squared minus 2bc cosine of a. So that gives us 37.9 squared plus 40.8 squared minus 2 times 37.9 times 40.8 cosine of 67.3. We fill all of that into the calculator and we get a value of 1907.58, but we don't want a squared, we want a. So take the square root of these and you get a number of 43.7. Okay, so we have our sides done. So now all we need is our angles. So at this point, we can go for angle B or angle C. It does not matter. What we do know at this point is this is my largest angle because this is my largest side. Okay, so I'm going to just go ahead and go for angle B. So sine of B over little b, which is 37.9, equals sine of A, which is 67.3, over little a, which is 43.7. So angle B equals 37.9 sine of 67.3 all over 43.7. Throw this lovely thing into the calculator and we get 0.8000. And then I can identify, oops, this should be sine of B. Just saw what I did. So B equals the arc sine of 0.8000, which gives us an angle of 53.1 degrees. And now we can just use what we know about in geometry. Angle C is going to be 180 minus the 67.3 minus the 53.1, which gives us an angle of 59.6. Again, we can double check smallest side, smallest angle, largest side, largest angle, that our answers are reasonable. Okay, so at this point, we're going to cut it off for part 1, and we'll get part 2 soon.